Good morning, class. I have temporarily disabled comments so that I could share
Good morning,
the
class.
YouTube link.
Good morning, sir.
Morning, sir.
So please do share.
Morning, sir.
As I'm pasting it now on the Zoom. I'm pasting it many times. Share it with others. So I can only start if I'm convinced that enough people have joined us on YouTube. So I'll be watching proceedings if I can start. Yes, I can see many are joining on YouTube. So let's also give like 2-3 more minutes to be sure that enough have joined. So if you're on YouTube, just say hello, sir. Okay, I think we are set. So let's stretch our hands, our legs for 2 more minutes. So by 8:04, I will make the lecture starts. How was the convocation last week? Because for most of you, that will be the first event, big event you are seeing in Unilag. How was it? The people I'm asking are YouTube people. I know on Zoom, I have disabled comments. Yeah, it was good. So hopefully by God's grace, in the next 4 years or 5 years or 6 years, as your program may be, you will also be celebrated. You wear your red gown, carry your dancers and music people, and also come out on the stage to be recognized with your 5.0 or 4.9 something or 4.8 something. Nothing will come against that.
Amen.
By God's grace, inshallah. Amen.
Alhamdulillah.
All right, let me get my slide. Okay, before I get my slide, so let me greet everybody again. Good morning, good morning. To see my face. Last week, when we started our lecture 4, which is lecture 1 by me, we stopped somewhere, if you check the video, and I promise that we will complete it. So I'm here to complete it quickly so that we move on to what should be today's lecture. We are not able to complete it last 2 weeks, not because of time, but because I was called for another very, very important meeting. So, but this time around, we'll finish it. All right, so let me share the slide. You should be able to remember that's where we stopped. I hope the YouTube people are following, coming, sharing it. All right. If you're on YouTube and you can see what I'm displaying on the screen, the title is Types of OS Software. Please say I can see, please, on YouTube. All right. You're on YouTube and you can see. Okay. All right. So, okay. All right. So we start. I use my phone to log in on YouTube so that I will be monitoring the madness going on there. Let me have mercy on those on Zoom to allow them to also talk. But mind you, some students came to Unilag to distract others. Remember, some their parents are very rich, that even if they fail, they already have something for them. But you that is struggling, make sure you are not deceived. Secondly, some will just be chatting, bringing up jokes unnecessary or excessively. That also could be a distraction, and you might just be carried away and start laughing and joking and playing around. So please also take note of that. So let me enable group chatting on Zoom. I think it should be meeting group chat. I mean, the one I think it should be this. Okay, can someone say hello on Zoom, please? Let me be sure that I've enabled it. Hello on Zoom. Okay, okay, all right. So,
Hello.
last week, last 2 weeks, we missed last week because of a convocation. 1 minute, let me record this so that I will greet again and it should be on the records. All right, good morning, class. How is everybody? How was our 1 week holiday? So today we continue from where we stopped. And that was here now, types of operating system software. I've gone through this and I've asked you to now study more on them, these types of software. There are subtle differences. Their names are self-explanatory and it could help. Please, I think I will have to disable comments again because you guys are using it to write your matric numbers, which is simply not acceptable to me. So I'm disabling it again. 2 students have written that they can't hear me. Can you hear me, please? So that we know whether it's the student from my end.
Yes, I'm fine.
Yes. For you do. Come on me for the room, sha.
Wait, what is happening? Please, can you hear me? Okay, Zoom, YouTube is saying they can hear me on Zoom. Oh, sorry, I disabled comments again. Now you people, they cause them now. Okay, I've enabled comment on Zoom. Zoom, guys, can you hear me? Yes, sir. So, Damilola Olaye, the problem is clearly from your own side. Maybe your village people have come again. So see whether you can call your grandfather or grandmother and say, please, daddy, go and beg them. So the fault is not from my own end. All right, so let's start. So I go to the next slide because this is where I stopped. So the next slide is components of an operating system. We've talked about operating system. Now let's talk about components of an operating system. Before I talk about components of an operating system, permit me to move back to a particular slide to enable you know how we are moving. This is where we started. Let me bring this slide. This is where we started so that you don't get confused. Under computer software, we talked about system software. I have not gone to application software yet. So under system software, check the next slide. System software into 3 categories: operating system, utilities, and translators. So we are still under operating system. So mind you, so after operating system, when you see a slide on utility, you will understand what is going on. After that, we'll now talk about language translators. You will also understand what is going on. Okay, so let me go to components of an operating system. We are still on an operating system. The OS, that's what I might be calling it sometimes, consists of several components that help manage hardware and software resources. But the 3 key components are what you are seeing on the screen, the kernel, the user interface, and your API, application programming interface. Now, the kernel is more or less the core. That's C-O-R-E, the core part of the operating system. Even the word kernel is something core, foundation. So it's the core part of the OS. And what does it do? It is responsible for managing hardware resources. Example, memory, CPU, input and output devices. Let me come again. The kernel is the core part of the operating system. It manages hardware resources, full stop. Then if I ask you what kind of hardware resources, you know what is hardware because you have done it with Dr. Ogude. Your memory, CPU, input and output devices, and others. I believe we know what is input and output devices. Keyboard, mouse, they are all input devices. Output devices, the monitor, the peripherals you attach, like the printer is output device, scanner is input device. All those devices are managed by the core, which is the kernel. The kernel also handles processes, and it ensures that different software applications can interact efficiently with the hardware. There is something you plug into your laptop, and if you don't install an application, it will not work. So the kernel is responsible of ensuring that that application can smoothly interact with the hardware efficiently. There were a time, most of you maybe were still babies or were not born, when laptops were owned by only the rich. What was obtainable then was generally the big desktops. Then when you buy keyboard separate, because you buy keyboard separate, you buy mouse separate, you buy your monitor separate, you buy your system unit separate. When you buy keyboard, you are always required to install the application that will make the system understand that keyboard you're attaching to it. So if you just buy keyboard and attach to it, it will not understand. It will not know what is happening until you install application. The kernel is responsible for ensuring that that application can interact efficiently with the hardware. I think I'm speaking like one popular bishop. The voice, the way I'm saying it, slowly, quietly, and loud. Okay, the second one, user interface. Interface itself is an English word. And it's like more or less something at the middle, something through which you pass, something through which you interact with something else, blocking you from, it's at the middle, you are on one side, interface at the middle, something is on the other side. So the user interface is the component of the operating system that allows us to interact with the computer system. It could be a command line interface. Nowadays, we don't have that, mostly for civilians. It could be your graphical user interface that allows you to run programs, manage files, interact with the system. Let me give an example. It's something you do every day. When you on your laptop, apologies to those who don't get laptop, or when you on your phone, whether it is yours or a stolen phone, when you on it, there is something you are seeing on the screen. There is something you are seeing on the screen. Your phone is not dark. You are seeing, for example, your icons, applications icons. That whole face on your screen, that's the interface, ladies and gentlemen. You want to open your UBA app. You will use your eyes, two eyes first, to look at the screen. Scroll down or scroll up or scroll left or scroll right to get the UBA app before you can touch that icon and your app will open. So that the interface is the whole surface of that your phone, of that your laptop, that is helping you to interact with the system. You have some files or some videos saved in your laptop. How do you have access to those files? You will, first of all, on your laptop, something will show, the screen will show, because it is showing your eyes is understanding, then your eyes will now start browsing where you saved that file. So it allows users to run programs. That you can run your program, you can open your software, you can install. It allows you to manage your files on your laptop. You can delete, add, do whatever, modify. And it allows you to interact with the system. You and your laptop, how do you talk? The laptop has no mouse to talk. So interact by, using your mouse, clicking, opening, doing this or that, thanks to the user interface. Then lastly, API, application programming interface, is a set of rules and protocols. By rules, sometimes I find it difficult to pronounce R very clearly. R for Ronaldo, do and for Messi. But let's continue. So it's a set of rules, R-U-L-E-S. A set of rules and protocols that allows different applications to communicate with each other. So it's like it defines the methods and data structures that the developer can use to interact with a service, system, or library. For example, you installed WhatsApp on your phone. There are some protocols that will make your phone understand what WhatsApp is to do. There are protocols that will ensure that your WhatsApp is working correctly and efficiently. A set of rules and protocols that will allow that application to communicate, with another WhatsApp installed on another phone. So this API define the methods and the data structures that developers can use to interact with a service, system, or library. So in simple terms, ladies and gentlemen, an API acts like a bridge between different programs, allowing them to exchange information or request services. So another example is when you use an app, let's say on your phone, to check the weather. That app may use an API to request data, weather data from a remote server. All right. I hope you can hear me clearly, and I hope you can see my screen both on Zoom and both on YouTube. Let me check the, okay, everything is fine. So someone said I should repeat about the API. So I said API is a set of rules and protocols that allows different software applications to communicate with each other. Different software applications to communicate with each other. And I use a simple example. If you have an app on your phone, weather app, here in Africa, we don't normally install weather app, but abroad many people, as you have WhatsApp, so do they have weather applications to always check what the weather will be today. Will it be snowy, or will it be a rainy day? So as to know the kind of dress they wear. But here we are blessed, every day is almost sun. So that app, now you touch it on your screen, it opens, and you want to know, the weather, temperature, etc., humidity. You are not typing that question there. You just click on it. The app will open now and display temperature, weather, this and that. Where did he get the information? That app is using an API. That API requests weather data from somewhere. Where is he getting the information? There is a server somewhere now monitoring the weather and collecting information. So any other application from anywhere in the world that makes a request, making request is you click on that icon for it to open on your screen and show you the weather. So once you click, it's a request you have made through API, it will send that request to the main server somewhere. Okay, I need the temperature, I need the humidity, I need the wind speed, wind direction, etc. Okay, we move on. So we are done. Now, the next screen, utility software. I hope we are not confused how I landed here. Let me go back to my good slide. We are done with operating system. We are now on utility software. That's how we landed. Let me go. So it is called utility software or utilities. So utility software, guys, refers to a type of system software maintain, optimize computer systems or devices. This is where the key difference is coming in now. Operating system is more or less sorry, there was a network failure. So I needed to quickly change my Wi-Fi connection. So sorry, I have to ask the question again. Can you hear me now? I was temporarily out, but can you hear me now? All right. Yes, so let me wait for the YouTube message to reach. It takes some seconds before our message gets to YouTube. So they are still writing, they can't hear me, so I'm waiting. Okay, they can hear me now. So sorry, there was network failure. So it might still be happening. When it happens, calm down, we'll sort it out, and we'll continue. All right. I was here and I was trying to tell us how you differentiate. Although the examples, you know them, utilities are mostly to take care of your system, to make sure your system is not sick. Let me put it that way. So they are designed to help you manage, maintain, and optimize your computer systems or devices. And utilities perform a variety of functions that make the system more efficient, more secure, and easier to use. They typically handle tasks like file management, system cleanup, data backup, and virus protection. Let's look at the screen. The first example is antivirus programs. You know them now. They protect against threats to your system. There are some antivirus programs, when you install it, it will not allow you to click any malicious link. You see, it's trying to protect you and your system. Let me pick another one. It's just, I will not pick everything straight away. System monitoring tools. These applications, what they do is to track how busy is your CPU, how busy is the brain of the computer. If it is so occupied, it will alert you to please close some applications that you are not using. Close some services that you are not using, that the CPU is being overwhelmed. Also memory, it can even trigger an alert, text alert, telling user, try and just be downloading things on your phone, on your laptop. At a time, you get a warning that your memory is getting filled up. These are pre-installed system monitoring tools. Yeah, so I've written them for you to read and see the description beside. Backup software, it creates copies of whatever you have in your system in case your system fails. This is very popular when desktops were popular. Now laptops too, yes. And there are very different kinds of backup systems. Even on your iPhone, there's a backup system which is in the cloud. There's also one that you can attach to connect to your phone and back up your data in case something happens to that phone. It falls into water, falls on the ground, or the laptop itself is stolen, etc. Then the second one on the screen, I just picked them randomly. Disk cleanup tools. Phones, smartphones, they do have all these apps. If you go to any app store or any app store actually for iPhone or for Samsung or for Android, you will have so many of them. Their job is to scan your phone or scan your laptop or scan your system to find unnecessary files so that they will ask you, do you want it to be deleted? To free up your storage space. Unnecessary files, by that I mean, for example, when you guys take picture, you might take picture like that's 10 times, that's 10 pictures and they are just the same. So such cleanup tools can locate such photos and tell you that this is just a duplicate. You want us to leave one and delete the other 9. No, deleting the other 9 will definitely free up space. Or a very, very old file that you have not touched in the past 6 years. It will also bring it up. Look at this file. Do you still need it, etc. Utility software isn't typically essential for the system to function, right? It is not there to make sure that the system is functioning. Unlike operating system, without operating system will not function. But without utilities, system will function. However, what utility does is to improve system efficiency, to improve user experience. You know, when you are sick, you can still walk around, you can still shout, you can still eat for some people, you can still talk. But when somebody is dead, he cannot do anything. So operating system, if the operating system is not there, the system is down. But if utility is not there, the system is sick, but can still operate, but might not be efficient. All right, please, am I communicating? Oh, sorry. I muted myself. But thank God I've not done much. I asked a question I was waiting for you to answer. I haven't done much. Sorry, I muted myself. So, but I haven't got much actually. What I said was, please look at the screen, read it for 1 minute. Then, did you understand what high-level language program is? That was what I said. So there was nothing much missed actually. All right, I believe you can hear me now. Let me wait until I have a signal that you can hear me. Okay. Okay, so as I said, you haven't missed much. So calm down. What I said is look at the screen, read it for 1 minute, and see whether you can understand what high-level language is. But it's okay. So what are language translators? Language translators are programs that convert code written in high-level programming language into machine-readable code that a computer can execute. Let me explain the two terms there. What is high-level programming language? We will do it today. I will explain it more in detail, but let me just give you an example. Example of a high-level language program is C++, Java, JavaScript, Python, C, Ruby, etc. All those programming languages that are used to code, they are called high-level language. I will explain what high-level later. Now, language translators, let me start with the fact that computers understand only one language. Computer does not understand English language, does not understand Yoruba, does not understand Igbo, does not understand Chinese language. Computers do not understand high-level languages. Computers can only understand a language we call machine language. Your laptop understands only machine language. Your ATM machine, POS, traffic lights, name them. Every computing device understands one language, which is machine language. And machine language is 0 and 1. That's binary system. That's what machine language uses. In English language, which letters do we use? A, B, C, D, E, F to Z, 26 alphabets. Machine language has only 2, 0 and 1. So a combination of it, your name can be converted into zeros and ones. That's the only language computer understands. So the job of translators or language translators is to convert these high-level languages, C++, Java, C, Python, etc., is to convert them into machine language so that the computer can understand and execute the instructions there. After all, we were told last 2 weeks that computer programs are a set of instructions telling the computer what to do and how to do it. So if those sets of instructions are in a German language, computer will not understand it. So those languages must be converted to machine language so that a computer will be able to read, interpret, and execute the instruction content in those languages. So that's the job of language translators, converting code written in high-level programming languages into machine-readable code. The name high-level will be explained shortly. Now, there are 3 primary types of language translators, as seen on your screen: compilers, interpreters, and assemblers. So let's talk about them a little, although I've explained each. Compiler and interpreter is always confused by students. Assembler is easier to remember. A compiler translates the entire program into machine code at once. That's the keyword, at once, before any part of that program can be executed. So a compiler will translate everything at a time before computer will now, okay, thank you, converted, now understand it, let me execute. While an interpreter converts line by line, that's the difference. Let me see what I can giggle out, write something here. Let's say this set of code, these lines are code, something written. See the red line I'm drawing on the left of your screen. Now, this first line, this second line, third, fourth, fifth, sixth, seventh line. Now, the compiler will compile everything at a go before the system can now execute it. While interpreter convert 1 and it is executed, convert 2, the system will execute it, convert 3, the system will execute it, etc. So ladies and gentlemen, that's just the difference. Both are doing the same job. They are converting your high-level language program to machine language, both of them. The difference is how are they doing it? Compiler is doing everything, converting everything at once before it is executed, while interpreter is converting it line by line, directly at runtime. One is converted, it is executed. Another one is converted, it is executed. So that's the key difference between compiler and interpreter. But if you look at it, the two are doing the same job. As an assembler, it translates assembly language into machine code. So the three of them are converting into machine code, but the first two are converting high-level language, while assembler is converting assembly language. Assembly language, none of you saw it. It's still there, but before it was popular new systems that came up. Assembly language is more or less uses mini mix. M for mommy, N for nanny, E for elephant, and the rest. Mini mix. Mnemonic is like symbols, signs. Every language is like a language of symbols and signs. And it's easier when it shows that it's easier to look at that diagram or that symbol or that sign and say that this means this. Unlike when you are writing C++, everywhere is, machine language, you are seeing zeros and ones, you will not understand. If I convert your name to binary, you will marvel. Is this my name? But with science, yes. So assembler does his job to translate assembly language into machine code. May I remind us, or may I note here that assembly language is a low-level language, unlike compiler and interpreter that are converting high-level language to machine. Assembler is converting assembly language, which is a low-level language, to machine. I will come to this to explain what is high level and what is low level. Are we following, guys? Okay. All right. So was it last week that Chelsea lost? And on Monday, I said, thank God there is a convocation. Yes, I would have been finished. So that one is gone. I can't remember that Chelsea lost. What I can remember that we won 2 days ago. All right, so I'm moving. The next slide. Application software. Application software. Let me take you to that slide that you are sick and tired of. Okay, it's no more that one. We are going further up. No more this slide. Rather, this. Now, system, we are now moving to application software. So, apps, as you call it, APPS, application apps. All right. 1 minute. Let me get it out. So, application and specific activities. Unlike a system, what does use hardware and system resources? But application software you can I'm back. So as I said, whenever I'm back, network failure again. So I've told you, whenever the network goes out, calm down, I will resolve it. And I can't continue until I'm sure that everybody, both Zoom and YouTube, can hear me again. So please, can you hear me both on Zoom and on YouTube? Okay, so Zoom can hear me. Let me wait for the Zoom market to talk. Yes, I've heard you, Zoom. What do you call YouTube, please? Waiting. There are many on YouTube. So before you get all their messages out. Okay, so they can hear me now. Okay, you can hear me. And please, I believe you can see my screen too. I believe you can see my screen, the YouTube. Okay. Okay, so, when it goes off, I don't know what you heard last. Can someone, let me unmute somebody on Zoom to tell me what I said last? I know that once I unmute it now, noise everywhere. Okay, so one person can unmute yourself and quickly tell me what I said last.
You wanted to explain application software, sir.
What?
You were about to explain application software.
All right, thank you. So let me mute everybody back. So application software, I was saying that an application software refers to programs or applications, what you call apps, APPS, that are designed to help users, that's you and I, to perform our specific tasks or activities. Unlike system software, what does system software do? They manage hardware and system resources. They are not managing you and I. They are managing the system. Unlike that, application software is tailored to the needs of the end user. Examples are on the screen. I can explain what I mean by needs of the end user. Let's look at system software. System software like your operating system, your utilities, or your translators. None is helping you do your direct specific task. They are there to manage hardware, software, and system resources. But application software is there to do your own task. For example, on the screen, let's choose anyone. Games, the last one on your screen, games. Subway Surfers, I like that game. My son made me to like it. He can use one hand, but me, it's two hands to play it. Now, it is there to do a specific task for you, not for everybody, but for you alone. Fun. You want to catch fun, you want to play the game, fine. Media players, you want to listen to any music, your playlist, or your phone. That application there is an application software, not a system software, because it is tailored to the needs of you, the end user. It is tailored to you alone or to anybody who is an end user. Spreadsheets like your Microsoft Excel, you open it to do 1 or 2 tasks for yourself, maybe to write down the list of noisemakers or write down the list of people in your class with their matric number and the rest. Word processors like your Microsoft Word and other word processors, they are all there. These are applications tailored to your own needs, tailored to the needs of the end user. It is unlike system software that manages hardware and the system resources. So these programs, the one on the screen, open your smartphone. Most of the icons, not all, most of the icons you see on your phones are applications. They are apps, or you can call them application software. Any goes. Application software, apps, and applications. So these programs, they enable users, you and I, to do things like create documents, analyze data, browse the internet, your web browsers like your Google, Chrome, etc. They allow us to edit photos, those that will never put up their original photo, among many other functions. These are applications. These are apps. These are application software. There are other many other examples. So accounting application used in companies, for accounting purposes. Email clients, you have email software. You have file viewers. You have console games, database applications, and I've mentioned photo editors. You have flight simulators. Name them. They are all applications. Your calculator, it is also an app. Okay. The application is not hard to teach because it's what you relate with every day. So the next slide, I want to show us here that simple, that applications sit on top of system software because they are unable to run without the operating system and of course system utilities. Without your operating system, application software is useless. Why? Without your operating system, your phone might not on. So if your phone does not on, those applications you have there are useless because you cannot access them. So that's why I say, and I repeat, that applications sit on top of system software. The screen can show us there. You'll be wondering, but where is system software there? Where is system software? System software is there now. See operating system. Operating system is a type of system software. So applications sit on top of system software because they are unable to run without them. And of course, also somehow without system utilities. System utilities, make sure that everything is fine. Without antivirus, some of your applications might be infected. And once it is infected, that application might not work efficiently. So that's why I'm saying that applications are unable to run without operating system and in some cases without your utilities. That's why I just brought this diagram here. Okay, move on. Application software could be off-the-shelf software or customized, tailor-made, bespoke software. What is the difference? Off-the-shelf, the name off-the-shelf refers to pre-packaged software that is developed for a wide range of users. Pre-packaged software that is developed for a wide range of users. And is readily available for purchase and use, readily available. So it is not customized for a specific company or organization. However, rather, it's designed to meet the general needs of many users. Examples of off-the-shelf software, you have Microsoft Office suite like Word, Excel, PowerPoint. They are designed for the general needs of many users across the world. Your Adobe Photoshop for graphic design, your web browser, Google Chrome, most web browsers, they are all designed for general needs of many users. Accounting software, etc. And of course, under off-the-shelf, you have the general ones and you have the special purpose ones. The names are all explanatory. I don't even, if I promise someone 1 million naira and say, explain what is general purpose software, I think you'll be able to get something. So general purpose software, they are software applications designed for a wide range of users and tasks. Examples are your Microsoft Word, Microsoft Excel, that's your word processors, your spreadsheets, your web browsers, presentation software like PowerPoint. These are general purpose software. Special purpose software are designed for specific tasks or for specific industries. Example is accounting software. Like there is this accounting software called a Quick Book, book that you read. Quick, something that is fast. So one word, Quick Books is a popular accounting software. So you see, it's tailored only for accounting industry. Maybe it's used to take accounts of whatever in the company. Another example is Adobe Photoshop, the graphic design software. It's designed, of course, you know what it is. The ladies can tell us more, for photo editing and the rest. So you see, it's for a specific. That's why it's called special purpose. Then you have others for those heading to Idi Arab after 1 year, medical diagnosis software. And there are many of them that can be used in the medical industry to diagnose one disease or the other, to test for the existence of one condition or the other. You also have, there are many hotel management software. If you go to major hotels, they have a software that receptionist you are seeing there is looking at something on her screen. There are software they are using to manage which room is empty, which room has been occupied, etc., and how much per room. So these are examples of off-the-shelf software. The general purpose, I've mentioned them, your spreadsheets, your word processors, your web browsers, your presentation software, and the rest. Now, if you come to, I hope, can you hear me on YouTube? Someone is saying that my voice is cracking. Okay, you can hear me now. So thank God. So if you can't hear me on YouTube, then your village people is doing wonders again. Or apologies, might be my own village people, Sha. I don't know. All right, so we go to the right, customized, also known as bespoke software. It's a type of software that is specially designed and developed to meet the specific needs of an individual, business, or organization. So unlike the off-the-shelf, which is meant for a broad audience, the customized one is tailored to fit unique requirements. For example, a banking system designed for a specific financial institution. Let's say UBA app is a customized, because UBA app cannot be used by Access Bank, cannot be used by Zenith Bank, cannot be used by OPay. So it's designed for that specific financial institution. And I would like us, ladies and gentlemen, to be able to differentiate between customized and then this one here, special purpose software. No, they are key difference. Tailored for a particular industry, that's special purpose. But that industry can be big, like medical software can be used by any medical organization. But when we are talking about customized, it's now for a particular individual, a particular business, a particular organization. Hospital management system. Yes, I've called medical diagnosis software as a special purpose, but you can also have, a hospital management system built for a particular hospital. For a particular hospital that maybe a software that is used in medical center, Unilag Medical Center, but cannot be used at LUT, or something that can be used at Federal Medical Center, Uibo, Ibitemeta, but cannot be used at LASUT. So another example is there are many websites or mobile app developed specifically for a business, a website. So these are customized or tailor-made or bespoke software. So I'm done with the applications. The last slide of what's supposed to be last week's lecture, and we have 1 hour to go. Yeah, we'll still cover a bit of next one. language translators. So we are coming back again to that high level and low level. And this is just the last slide. So I will explain everything here. Computer languages are systems used by programmers to communicate instructions to a computer. So the language is, set of instructions for a computer on what to do and how to do it. These languages allow you and I, humans, to write programs that control the behavior of computers. And there are two main types of computer languages. The low level languages. What are the low level languages? Now, why is the name low level? Let me start with high level. Well, low level, sha. Low level languages means that they are closer to machine code. When a human being is standing up, right? We believe that our language is high. Computer language is very, very down on the ground. That's the funny way how the name came about. So low-level languages, it has been compared, and it is seen that low-level languages are closer to machine language, are lower to the ground than higher to the human head. That is the funny history about the name. So they are called low-level languages because they are closer to machine code. And low-level languages, they are often more efficient, but harder for humans to read and write. There are examples of low-level languages too. Machine language and assembly language. So it's not on the screen, so you listen. The two types of low-level language, machine language and assembly language. Machine language is already on the ground, so we call it low-level language. Assembly language is also closer to machine language than to human language. Human language is English, French, Yoruba, Igbo, Hausa. So machine language, of course, is directly made up of binary code, zeros and ones. And this is the only language that the computer hardware understands. While assembly language, there are the two types of low level, machine and assembly. While assembly language is a human readable representation of machine code, but it uses mnemonics instead of zeros and ones. But it still requires translation into a machine code. What translates assembly language to a machine code? Can someone answer on YouTube? What translates assembly language to machine code? I'm waiting for them to say something on YouTube. What translates assembly language to machine language? Assembler. Yeah, thank you. Assembler. So I repeat, the two types of low-level languages, the machine language and assembly language. They are called low-level because they are much the ground. I'm explaining how it came about. When a human being stands, our language is in our head, so we are high up. So any other language that is not resembling our language is a low-level language. Machine language, zeros and ones. Assembly language uses mnemonics, uses signs and symbols and special characters. Now, high-level languages. High-level languages are closer to human languages and are more abstract, making them easier to learn and use. They are closer to human languages. And C++ or C Python or C Java or C JavaScript, etc., or Ruby. If you see the code, yes, it is not pure English language, but you can understand some things. For example, integer. When you want to declare an integer in C++, you write int, I-N-T. So as a human being, when I see int, I will say, okay, this is an integer. Function in some languages are written out fully, function. So if you see it as a human being, you will understand. Unlike if you see 01100001, you will not know what it is immediately. You need to convert it to know what it means in your language. So that's why we say that these high-level languages are closer to human understanding. And at the end of the day, it's humans that write those languages. So some of the phrases, some of the expressions used are, are abstracts that can easily be learned and used by humans. So the high level, that's why it's called high. You see, That's where the name is. They are closer up there with human language. Our languages are what? English. Name your languages. So high-level languages are languages that are closer to them. Okay, and they are translated into machine code. That's the high level, just like the assemblers. They are translated using compilers or interpreters. And we know the difference between compilers and interpreters. One converts every code at once before being executed. For interpreters, the code is converted and executed line by line. So I'm done. I just give us 1 minute. I know if I say ask question, meaning we ask, I'll just pick one answer before I close this slide and open what should be today's slide. So go ahead, please. I'll also release those on, maybe this time around, let me pick question from those on Zoom. So you can unmute yourself and, or sorry, you can write. If there is no question, I move on. Okay, I'm asked to repeat what is a high-level language. So high-level languages are languages that are closer to human languages and are more abstract, making them easier to learn and use. High-level languages are what? Programming languages that are closer to human understanding, that are closer to human language. While low-level languages are languages that are closer to machine code, that are closer to machine language. So machine code is down, down, human language is up, up. So any language that is closer to the down, down one is low-level language. Any language that are closer to up one is human language. What do I mean by closer? I mean the syntax, the expressions used in writing that language resembles human language. That's why it's high-level language. So high-level languages are programming languages that are closer to human languages. And examples are the languages you know: Python, Java, C++, JavaScript, etc. What are the advantages of high-level languages? So find out that one out. That is why it is called a university. Mine is to open the door. Yours is to enter the door and find out where fruits are hidden and pick them. All right, someone is asking what application software is. I think that would be the last question. Most of you are hammering on application software. Let me bring it out again. So this is application. We started here, right? I gave you an examples here that there are application software are programs or applications designed to help users perform specific tasks or activities. Full stop. A program that are designed to help you, the end user, perform their specific tasks or activities. Full stop. And I came here that off-the-shelf software refers to prepackaged software that is developed for a wide range of users. You know, a software that you are not the one that went, paid for it and say, please do this software like this, do it like this for me. No, it is already there. That's why it's called prepackaged. Yours is to use it. You don't have influence on change it like this. My Microsoft is blue, make it red, or make this place it from left to right. No, they are prepackaged and they are developed for you, available for purchase and use by a wide range of users. It is not customized. I'm talking about off the shelf. It is not customized for a specific person or a specific business or a specific organization. It is designed to meet the general needs of many users. And I gave examples: Microsoft Excel, Word, PowerPoint. You have your graphic design applications like your Adobe Photoshop and other Photoshops. You have your web browsers, Google Chrome, Firefox, and the rest. You have your accounting softwares, etc. These are generally off-the-shelf software. You should check now. They are used by many people. Then under the off-the-shelf, you have the general purpose and the specific purpose. And I said the general purpose application designed for a wide range of users. Same definition of off-the-shelf, but you will see the difference between general and special. So the examples of general, your word processors, your spreadsheets, your web browsers, presentation software like PowerPoint. Now, special purpose. They are designed for specific tasks or specific industries. Accounting software is developed for accounting industry, any company that deals in accounting activities. Medical diagnosis software are designed for the field of medicine. So any hospital, any medical facility could get a medical diagnosis software. Hotel management system, I can develop a hotel management system for any hotel to use. They are special purpose because they are designed for a particular industry, but they are off the shelf because they are used by many people. Now, customize. The difference here is customize is designed to meet the specific need of an individual, a business or organization. Now, let me use hotel management that can be off the shelf, special purpose, or customized. If I develop a hotel management system generally, that any hotel can come buy it from me, that is now an off the shelf. I develop it generally without consulting any hotel. You come buy, install, and use. But if a hotel comes to me and says, please do it this way, put this for us, put this field in this, so that when those that want to book a hotel will see this and that in their website. Then when I do that, it is now a customized. It is now tailored for a particular person, for a particular business. But in special purpose under of the shelf is tailored for particular industry, the whole industry, not just a company, not just a person. I think I've done justice to that. So I'll be ending this slide to enable me move on and open the next. So give me a minute. I will stop sharing. I've shared this slide with you last week. So you already have it. So the one I'll be opening now, I haven't shared it with you before. So let me open it. Okay, so this is where our next lecture ought to start. About promise giving, promise kept, that we have to finish where we left. So we're starting now. So today's lecture, a continuation, should be on computer processing modes and computer networks. Now, 1 minute distractions from charts. Whenever you write, it pops up on the screen. Somebody asked, and I think I explained it. I hope this question came before I explained. Somebody asked on Zoom, the difference between special, not specific, special purpose software and customized software. Special purpose software is a general off-the-shelf software to start with, right? But it is designed for a specific industry. While customized software is designed for a specific organization or a specific person or a specific business. And I use a very, very good example. Hotel management system. Sorry. 1 minute. Let me remove my Zoom and my WhatsApp. That's where the call is coming from. And it is, okay. I use which is what? Hotel management system. A hotel management system can be special purpose. It can also be customized. When is it special purpose? It is special purpose when me, the programmer, I will sit and design a hotel management website or not website, application. That any hotel, the one at Shomolu, the one at Ikeja, the one at VI can come and say, "Oga, we need this your hotel management system." Our customers don't know how to book. They will just come to our office and say they want to book. Please develop this so that we can broadcast it, advertise it online. So that anybody that wants to book will use this thing. How much? I say it's 10 naira. They will pay and they will take my hotel management system and go and be using. That means any hotel can use it. All right? It is tailored for the industry, for the hotel industry. But now, if a hotel comes, say, yes, we have seen this, your hotel management system is good, but please, can you put the date on the right, not on the left? Can you put our logo here? Can you do this? Can you do that? Can you put our address down? That means I cannot sell that again to another hotel because it's bearing the logo of one hotel. You can't go and be selling it for other hotel. Now it is now customized. It is now tailored for a particular person, for a particular business. This Man U fans, I have to continue, please. So today's lecture on computer processing modes and computer networks. Computer processing modes define how your CPU operates and manages access to system resources. Remember, CPU is the brain of the computer. It is the CPU that manages, resources, allocation, which process do I allocate memory, which process do I queue up, etc. So the modes define how a CPU operates and manages the access to system resources. And the modes also refer to different ways computers process data and execute tasks. At the end of the day, still CPU. So computer processing modes, also called CPU modes, dictates how your CPU functions. By determining the level of access to system resources. And there are so many modes. We have user mode, we have kernel mode, etc. We'll be seeing it in subsequent slides now. What else do I add here? I hope you know what is CPU. Central Processing Unit. That's the full meaning of CPU. So next, we look at examples of different processing modes. Okay. So they are listed here. My job now is to pick them one after the other. Open your ears and listen. One, user mode. User mode is a restricted mode where applications, since they are running with limited privileges, prevention of direct access to hardware and critical system resources. There are some applications that does not have access to your critical system resources. So I come again, a user mode is a restricted mode in which applications privilege preventing direct access to hardware and critical system resources. So even if you don't understand now, I will explain. Even if still you don't understand, you still get the slide. Even if you don't get the user mode is mode for applications where access to sensitive system functions is restricted. The standard mode for applications where access to sensitive system functions is restricted. So the user mode is a restricted execution environment. I've been using this word, restriction, restricted, restriction. So in your exam, if you see restriction here and there, better go and check whether it's user mode. So it's a restricted execution environment where user applications and processes run. In user mode, programs have limited access. I'm repeating and repeating and repeating. In user mode, programs have limited access to system resources and cannot perform privileged operations like accessing hardware or modifying system settings. No. 2, kernel mode. It's a privileged mode, like user mode, that allows the operating system's kernel to execute with full access to system hardware and memory. So when the CPU is in kernel mode, it has full access to all system resources, and it can execute any instruction, allowing the operating system to perform privileged tasks like what? Managing hardware and memory allocation. These are very sensitive and privileged tasks. Management of hardware and allocation of memory. The third one, real mode. It's a legacy mode, but don't bother yourself with the word legacy. In some x86 processors. Don't mind again that. It provides what? Direct access to memory and hardware. But it was used in early DOS systems, not today. So real mode is the simplest operating mode of x86 processors. There are processors called x86. That's their name. So they are the simplest of those processors. Remember, processors are what? CPU. And we are talking about all these modes. Are we talking about what? We are talking about the mode of CPUs, the states in which they are. So real mode is the simplest operating mode of processors, old processors called x86. They offer direct access to memory, direct access to input and output devices. That's your hardware. So, and this mode is primarily used in early computer systems, such as MS-DOS and early versions of Windows, but not today. The fourth one, protected mode, is an advanced mode introduced in another processor. The processor is called Intel 8286. So you might not cram it, please. But if you like, because I might run crazy and forget and put it in questions in exam. For real mode, they are associated with x86 processors. For protected mode, they are associated with Intel 8286 processors. Remember again, the modes you are seeing on the screen, we are talking about the modes of CPU. So CPU is processor. So, and the protected mode enables features like memory protection, multitasking, virtual memory. It is a mode for CPUs that were introduced back then when you were still, your parents have not thought of giving birth to you. They were introduced in 1982, 83, 81, thereabouts. And they are used in all modern multitasking operating systems. I know these ones are hard, but I had to present them. The next, second to the last, supervisor mode, is a high privilege. When I talked about kernel mode, I said it's a privileged mode. For supervisor, I'm calling it a high privilege execution mode. It allows the operating system to manage low-level hardware functions and system calls. So essentially, ladies and gentlemen, it means that it allows the running program, that's the operating system, complete access to system resources and hardware. Thereby enabling it to perform sensitive tasks that regular applications cannot do. So it gives the highest level of control over the system. And the last one, not the least, SMM, our system management mode. It's a special mode used for power management, system security, firmware level functions, and it's a high privilege operating mode too, used for low-level system management functions. The assignment I will give us here is please read more about them. You can Google them: user mode, kernel mode, real mode, protected mode, supervisor mode, SMM. Read more. Don't only listen and go home. Read more, and this is the assignment I'm giving you. You are not submitting anything, but let it be known that I told you to read more on them, their features. Each of these modes, they play a critical role in maintaining security, stability, performance in today's computing environments. So the one with the least privilege is user mode. The highest is supervisor mode. For system management, the processor in this case is used just for power management, system security, and firmware level functions. And the rest. And then also try to remember the x86 processors associated with real mode. They are also associated with protected mode after the Intel 8286. All right. The next slide, data processing. Data processing is the process of collecting and manipulating data to produce useful information. You are not just processing and manipulating it. There is your intention, target, which is the useful information. Now, I have two data. Let me say 5 and 6. I can write it on the screen. 5 and 6. Now, I define what data processing is again. Data processing is the process of collecting and manipulating data to produce useful information. In our computer science department, when the students are doing their final defense, project defense, I develop this, I develop that. We start with data processing. Which data did you collect? What did you process in that data? Or did you just collect the data raw and start using it? Were there some data processing activities? If yes, can you tell us? So it's very important when you collect data, you process, and you have your intention. So for the umpteenth time, I say it again, data processing is the process of collecting and manipulating data to produce useful information. I didn't say you go and cram this, but to know what we are talking about when we say data processing. Now I have 5. 5 is data. I have 6. 6 is data. I want to find the sum of the two data, 5 and 6. So I will do 5 plus 6, and it will give me 11. So 11 is the useful information. So data process is the process of collecting. I collected 5. I collected 6. Data process is the process of collecting and manipulating. I manipulated 5 and 6 by what? Summing them up. Data process is the process of collecting and manipulating data to produce useful information. And I've produced my useful information, which is 11. I did not just collect 5 and 6, and why am I collecting 5 and 6? There is a reason. When you go to your ATM machine and you want to withdraw 5K, you first collect the data. The machine will collect the data from you, which is what? Your PIN code. First data. Second, welcome to Access Bank, blah, blah, blah. How much? You enter the amount, 5000, or you click 5,000. This is also data. Data is being collected. After that, you press, I don't know, enter or pay or next. The manipulation will start. The system will see, okay, the PIN code is correct. Let's check amount that this person has. Okay, he has more than 5,000. Then you will start hearing that very pleasant voice sound when money is counting. Grrr. So it's counting. So manipulation has taken place. It has merged your request of your PIN code was entered to gain your access. You put the amount. Now you click withdraw. So that withdraw is the manipulation instruction. And before you know, you get cash coming out, money you can touch. And that's useful information. So it's a type of information processing, which is the process of changing information in a way that can be observed. Now, on the screen, you have steps. Let me clean what I've written there. You have steps in data processing. I want us to take a minute, 20 seconds to look at the steps here, collection, preparation, look at it, meditate on it, 20 seconds. All right. These are the steps. Remember, you'll be saying, I will get the slide, I will get the slide, but I did not explain anything collection. I did not explain anything preparation. I did not explain anything input on the slide. So I will explain it now with my mouth. Collection. So the steps involved in data processing generally. First, you must collect the data. So you gather the data from sources like warehouses or what we call data lakes. So you get your data somewhere. So that's my own. You get your data from somewhere. Maybe you want to know how many computer science students. Hello, my fellow computer science students. You want to collect data. Wait. Who is unmuting himself? I did not. All right. So you want to know how many computer science students are in 100 level? Not only that, sorry, you want to know among the 100 level computer science students, how many of them are female? So you have to collect the data first, Abi. You have to collect all the list, maybe matric number, name, gender. Then after that, you can now sort them. That sorting is the manipulation. Now sort them into genders. So male one side, female one side. So if, for example, you have 80-something students, those that were graduating, we had, they were gongo, my students, I was their supervisor, they were 80-something students, 70-something, some dropped off. And out of the 70-something, around 15 we have female. Can imagine. So I hope there are enough female now in our 100 level computer science. So you sort it out as the manipulation, and your useful information is what? You've gotten the number of female students in 100 level computer science. So, but I've gone far. I needed to stop at number 1, collection. So you have to gather your data from somewhere. 2, you have to now prepare. Preparation means like you clean. That's the word we use in computer science. You clean your data. You clean and format the data to make it accurate, consistent, and usable. So this involves checking for errors, duplicates, and missing data. You collect the list of the 100 level computer science students. You check whether there is duplicates. Maybe whether Ayo appear twice, or whether there are matric number appearing 3 times. You remove those 2. These are what we call processing, data processing. You also check whether there is a name that has no gender. You remove it, or you try to find what's the gender. You also try to check whether there is a name that has no matric number. You check whether actually is it a fake name. If all the matric numbers, in ascending order are filled up, you remove it. So these are preparations. You clean and format the data to make it accurate, consistent, and usable. Inputs. You add the data into a computer using an input device like a keyboard. But in my own example, we have already inputted it because I assume that we are doing it on Excel. However, you can also do it on paper. Oh yeah, everybody line up. Number 1, your name, matric number. 2, your name, matric number. 3, your name, matric number, and gender, etc. You now input it in a computer because data processing here we are talking about in a system, in a computer, not manually. So that's input and processing. You now alter the raw data to create usable information. That is, you can now arrange them in ascending order. Sorry, not in ascending order. I'm used to doing that. You arrange them based on gender. In Excel, you can arrange based on a particular factor. So based on gender, male or female. That's processing. Then outputs, from there, you present, you can see the number of female, the number of male, they will be separated. And that's it. You have your data. Storage, you store it. Why are we storing it? Maybe for future use. But in cases where there is no future use, then storage should not be in the list. So you store it for future use. If done, you've gotten the number, then you store it in the system. That is data processing, ladies and gentlemen. And I move to the next, which is types of data processing. Batch processing, real-time processing, online processing, distributed processing, and time-sharing processing. Now, the best way to pass this course or to understand and not to cram, remember, look at their names. Their names can make you, try to guess what they mean. Batch, something in batch, that means in group. What is batch processing? Data is collected over time and then processed in bulk. Bulk means B-U-L-K, bulk. So data is collected over time, with time, not just you collect one, you process. No, you accumulate, and then process in bulk at a scheduled time. So I don't want to bring here now, be blowing grammar of definition. I don't want to be defining what is batch processing. Batch processing is blah, blah, blah. I just explain it. You now interpret it as you understand. That data is collected over time and then it's processed in bulk at a particular time, at a scheduled time. Example is, let's say, payroll processing. Payroll is payment of salaries. Let's say all the lecturers in Unilag, they are not paying me now every day. It's every month, you see, at a scheduled time. The system, nobody is there sitting to start calculating by hand what this person will earn, what that person will earn, etc. It is automated. In fact, what am I saying? This slide is to introduce it. Then the next slide, batch processing is dedicated to one slide, real-time processing is dedicated to another slide, etc. So let me just give a summary here before we move on to the slides for each of them. So batch processing, data is collected over time and processed in bulk at a scheduled time. In real-time processing, data is processed instantly as it is being received. In online processing, it is similar to real-time processing, but typically involves multiple users accessing the system at the same time. Don't worry, we have slides for each of them. And in distributed processing, here data is processed across multiple computers and servers. That's why you see the word distributed. Systems, computer servers are in different locations. The data is processed across them. We give an example too. And the time sharing, multiple users share processing power simultaneously, and each user gets a time slice. Now, let me go to the first one, batch processing. So before I start speaking, let me run you through each of the slides, just see how they resemble. They are the same. Characteristics, examples. Characteristics, examples. See the next, real time. The next, online. The next, distributed. So the structure is the same. The next, time sharing, and we stop there. So let me go back to batch processing. So batch processing, as I started to say, is a method, data processing method, where large volumes of data are collected, stored, and processed together at a scheduled time, rather than being processed immediately. Collected, stored, and processed together at a scheduled time. This method is efficient for repetitive tasks that do not require real-time interaction. Characteristics on your screen, one is delayed execution. Data is processed after a certain period of time, or when specific condition is met. Like I was trying to use our payment payroll this thing. Every month, the system will calculate our salaries. Maybe someone has gotten promotion, or somebody was demoted, or one thing or the other, and your salary is recalculated before you get your money. So you see, details have been collected for that whole month, kept there on 28 or 29 of that month. Salaries are now processed for payments. The second characteristic there is automated. It requires minimal human intervention. This is a very big characteristic of batch processing. Minimal. Once the process starts, it's minimal. I was trying to use our salary payment system to call it payroll management system. It's not a human being sitting there to always compute how much will this person get, how much, no. Or what is the school fees of each student. It is automated and involves minimal human intervention. Efficiency, it handles large amounts of data at the same time, thereby reducing processing costs. Instead of dealing with each data, for one employer, you deal with that, second employer, you handle, it handles large at the same time, thereby reducing processing cost. Sequential execution, tasks are executed in a sequence, based on priority. And error handling here, I mean that errors are usually detected and corrected in a later batch run. So when the process is going on, errors might not be detected. Errors might be detected in a later. I still use salary payroll management system. I receive my salary, should be 20 naira, and I'm receiving 15 naira. It's already late, so that will be factored in the next month's pay. So in the next month's pay, my missing 5 naira will be added there. So examples of batch processing, you have the payroll processing, that's the salary I'm talking about, bank transaction, like your check clearances, or even your bank statement. If you come for bank statement, right, you want to know what you have spent from that, your empty account from January 1 till today. You see, it's for a time period, data has been accumulated. See, this is the definition of batch processing, and then it processes your request, and you get your bank statement from January 1 till January today. Utility billing, that's your electricity, we call it NEPA. Your phone bills, they are generated in batches at regular intervals. You subscribe for internet, though you still come around to still, like internet. At the end of the month, I didn't say at the end of the day, at the end of the month, well, if it is a monthly subscription, at the end of the week, if it is a weekly subscription, at the end of the day, if it is a daily subscription, but at least there is a certain amount of interval during which data has been accumulated, and you now get your bill that, see, your data is remaining, but your subscription has expired. Kindly subscribe again so that we'll roll over, stuff like that. All right. That's batch processing. That's the highest I can go with it. The next is real-time. So real-time processing is a data processing method too, where data is processed immediately as it is received, providing you instant or near instant outputs. And this method is essential for time-sensitive applications where delays can impact operations. So one of the characteristics is that it has instant response, processes data as soon as it arrives. Unlike batch. Batch waits for a month, for a week, for a year, for 10 years before processing. And 2 is continuous input and output. Data flows in and out without delays. It is highly reliable because the systems must function with minimal errors or with little or no downtime. The 4th one, concurrent processing. Here, I mean that real-time processing systems support multiple users or systems at the same time. And low latency, here we are talking about the processing time. It reduces processing time to barely milliseconds or microseconds. Examples always make things clearer. One is your online banking transaction. So when you go to your app to send money, everything being equal in a normal situation, the money you're sending goes, as you log in, put your password, enter the receiver's bank account number and bank name. These are information you're gathering, you're entering, and you click send. The transaction will be executed almost immediately. It doesn't say, okay, sir, thank you. Tomorrow, he will receive the money. No, it is instant. There are other stock market trading. Let me take those that you can understand. The 3rd one there, traffic control systems. I know in some of our traffic systems, most of our road traffic systems are not smart. Abroad, they have a smart control system. How? If at a junction, traffic, junction, that's 2 roads crossing each other, road 1 and road 2. Let me draw and explain what I mean. See road green and road red. So at their junction here, it's traffic lights. So if there is too much traffic on red and less traffic on green, the traffic light will adjust and make the traffic light guiding the red line to be showing green for a longer period, to be showing green light for a longer period so that the traffic can pass. But here in our own line, even if traffic did there, it will still stay till there. Most of you that use public transport, if you pass through Sabo, that traffic light there, that's you are moving out. You are heading, let's say, towards Third Mainland from Unilag. You reach Sabo. That red light there can hold you for God knows when, even if the intersecting road is clear. But abroad, most of the times, that our lights will change to green Once its sensor sees that there are many cars on that queue waiting, but here you go wait tire. All right. Okay. That's traffic control system. So it's like adaptive traffic light. They adjust based on real-time congestion. So what is happening at that time? At that real time, we determine how their traffic light will change. You have for healthcare monitoring system, also given as an example, all these live support systems and wearable health devices, tracking your vitals in real time. If somebody's in ICU, intensive care unit, there are so many things connected to the person breathing and the rest. So, and it is tracking the person's condition in real time right there. Well, another example, fraud detection system used in banks, used by credit card companies to detect and block suspicious transactions instantly, even if it is 12 midnight and the system notices that some, funny actions are being taken on a particular account, then that system might be blocked in real time immediately. They have advantages, have disadvantages. One advantage for those that would like such questions is like real-time processing facilitates immediate decision-making. And immediate decision-making is essential for critical applications like healthcare and finance. Another example could be better user experience, improved security, etc. One disadvantage is that high cost, because it requires advanced hardware and software for continuous processing. It's not easy to keep that ATM machine there 24/7. So it's high cost. Okay, let me leave it there and move to online processing. Somebody's writing here, they may have another classes, maybe they have another class. No, I don't know whether anybody has another class. This class should last till 10 o'clock on the timetable, official timetable. Okay. It is also known as online transaction processing. It's a method of data processing that uses the internet, that's the keyword, internet, and computer equipment to process data in real time. Mind you, your ATM machines, they don't use the internet. It's a network of their own. But online processing uses internet. Sometimes we confuse online processing with real time. So online processing uses the internet and computer equipment to process data in real time, but it's not a real-time processing method. So it's used to respond to user inputs and process transactions. So in this method, data is entered, processed, and updated in real time. Typically through an interactive system that allows multiple users to access and modify data. Some of the characteristics, one is instant data updates. So changes are immediately reflected in the system. User interaction, users actively input, retrieve, and modify data. The multi-user access supports many access by multiple users, simultaneous access by multiple users, etc. Examples, e-commerce transaction. You have the Amazon, you have Jumia. These websites, they process orders and payments instantly, that's real time, and it is via internet. Okay, hotel, airline reservations, the booking systems, they allow real-time reservation and cancellation. You can book a hotel, you can book a flight there, real-time, and also cancel it. So these are some examples. POS systems, retail stores process their sales transactions instantly. Advantages, real-time data accuracy is there as an advantage. Convenience, users can perform tasks anytime, anywhere, once you have access to the internet. Disadvantages are also like high infrastructure cost, because it requires powerful servers, databases, and security systems. Another disadvantage is cost, general cost. Since you are talking about internet, that means you will have access to what? The internet. You have to have access to data. So that's where the cost comes in. All right. The next is distributed processing. When you hear about distribution, that means computers and servers are located in different geographical locations, but they are working together to process that particular data. Computers, multiple computers, are located in different geographical locations, but they are working together to process that particular data. So this approach improves efficiency, scalability, and fault tolerance. Why? Because tasks are distributed across multiple systems. It is not just one system taking up all the headache. So instead of relying on a single machine, the tasks are distributed across multiple systems. So distributed processing is more or less a method of dividing a task into parts and executing them at the same time, but on multiple computers. So one of the targets is to improve speed, to improve efficiency, to improve reliability. One task divided into different parts. One part is being executed by one machine, by one system. Another part is being executed. Of course, it will be fast than one system handling every task. So one of the characteristics, number one, there is decentralized. I think that is clear. Tasks are spread across multiple computers. 2, parallel execution. Multiple tasks run simultaneously, thereby improving speed. As I'm explaining, I'm also talking about advantage or disadvantage. Fault tolerance. Here, I mean that if one node, one computer fails, others continue processing, thereby reducing system downtime. Scalability, by scalability, I mean that new computers can be added to handle increased workload, and others. Examples, your cloud computing, your Google Cloud, Azure, AWS for Amazon. So here, data is processed across multiple cloud servers. You can put up something in the cloud and give access to a friend or someone else to also manipulate the data or do something with that data you put up in the cloud. I don't want to talk about blockchain networks. The cryptocurrencies, I think trading in crypto is forbidden in Nigeria, if I still remember. Like Bitcoin and USDT. So they rely on a distributed network for transaction verification, if you know what is blockchain network. So if you don't know, forget about it. Your search engines, like your Google and other web browsers. So it's also cloud, the web crawling, indexing, they are distributed across global data centers. Another example, distributed databases, for example, let me see, Apple has so many databases. They are distributed. It's not just one located somewhere in California. No, one can be in California, one can be in New York. I don't know whether one can be in Shomolu, or one can be in London, one can be somewhere else, in New Jersey, but containing the same, and they are dealing with the same data. All right, I leave it here. Last but not the least is time sharing processing. So time sharing processing is also a data processing method where multiple users or multiple processes share the same CPU resources, but by dividing the processing time into small time slots. So multiple users are sharing the same CPU power, but they divide the processing time into small time slots. So each task, gets a brief moment to execute before switching to the next. So creating the illusion of simultaneous execution, which actually it is not. So time sharing is a computing technique, very popular computing technique that allows multiple users or multiple programs to share a computer's resources at the same time. So it's a way to efficiently use a computer processing time by dividing it into smaller slices or intervals. The characteristics are there: multi-user system. It allows multiple users to interact with the CPU at the same time. 2 is CPU time division. The CPU allocates short time slices to each task. fast switching. The system quickly switches. That CPU allocates its time. Let's say there are 100 tasks. It allocates 1 second to one task. After 1 second, it moves to another task, whether executed or not. Like that, it goes round, round, round in a loop until all the tasks are executed by the CPU. And other examples. All right, so I'm sensitive to the time for those that might have another class to prepare for this. So this lecture remain only 3 slides. And I wouldn't want us to that. So these 3 slides will be looked at in our next lecture plus our lecture of next week. And that will be it with me before I now move on to the next instructor. So hopefully we finish our remaining 3 slides. Then we'll move on to what our actual lecture should be next week. All right. So thank you for listening. If you have questions that I could not answer here, please kindly pass it through your course rep, class governor, course governor. They will reach out to me via WhatsApp. So don't reach out to me if you are not a course governor, course rep. And when you reach out, don't say good afternoon, sir. Good morning, sir. And you are waiting. That good morning, sir. Please stay there till next year. Good morning, sir. You move on with what you want to say. I'm so person. So this. And these are the questions that some of my classmates are asking. All right. Thank you very much. Enjoy the rest of the day. So after some while, I will share the record of this lecture and also the slide. So those on YouTube, can you say goodbye, sir? Those on Zoom, can you say hello, sir? All right, thank you. Thank you on Zoom and on YouTube. I'm waiting for your goodbye, sir. All right, so because I wanted to make sure everybody is following. At table, Sandra, I'm seeing your screen. Is it your house you are in? Or you are somewhere? No light, the fan is not turning. Why? I know you cannot speak, Shy. I muted you, but it's okay. All right, everybody.